Welcome back, students, to part 2 of the video for section 5.5, where we're looking at the remaining identities and formulas for this trigonometry unit. So the third example has to do with what are called half-angle formulas, and they're kind of like the cousin of the double-angle formulas, but they go the other way. So let's take a look at a numerical example, and your assignment today is just going to have numerical examples. So let's evaluate find the exact value of the sine of 105 degrees. If you were to look on your unit circle, you would not find 105 degrees on here. However, you do see a 210 degrees. So we can use this notion to find the exact value of the sine of 105. We'll do it this way. We're going to say that the sine of 105 degrees actually is the same thing as the sine of 210 degrees divided by 2. And once we have it written that way, you can see that we can use this first half-angle formula to go ahead and rewrite it. So we're going to rewrite it this way. This will equal plus or minus the square root of 1 minus the cosine of alpha, alpha being this number on top, so 210 in our case, divided by 2. This one actually, I've not seen it come up very often in calculus, but it's good for you to know that it exists and how it works. So let's see, the cosine of 210, just looking on my unit circle, I can see that it's negative root 3 over 2. And since the cosine of 210 is negative root 3 over 2, this will become plus root 3 over 2 divided by 2. At this point, we can simplify this considerably. So I'm going to go ahead and bring that 1/2 to the front, that divided by 2, because I want to make this a little bit prettier. This is a compound fraction under a square root. It's really gnarly. So let's try to clean this up a little bit. One thing I should consider, by the way, I should consider where this angle lies. And 105 degrees is about right here. So all students take calculus. And since I'm looking for the sine of 105 and it's in the second quadrant, I know it needs to be positive. So I can go ahead and drop this guy because this particular angle has to be positive. Now let's go ahead and distribute. So I'm going to get 1/2 plus root 3 over 4. I'm going to get a common denominator so I can put those fractions together. My common denominator is 4. And you can skip some steps, of course. I'm showing every single step here because I don't want to lose anyone. And now taking the square, I can't take square root of 2 plus root 3, but I can take the square root of the 4, so I will. And therefore my final answer is going to be the square root of 2 plus the square root of 3 divided by 2. If you enter this in your calculator, which I did, you'll end up with 0.966, and that is in fact the value of the sine of 105 degrees approximated. This is the value exactly. And if you recall from a unit circle, remember the sine is the height. This has a height of 1 right here. So this at 105 degrees has a height of approximately 0.966. So that's the half-angle formula. The two examples in your assignment today are going to be entirely numerical examples. So no x's and y's, just you have to follow this process here. Pretty easy. And let's go ahead and take a look at example 4. Now the next formulas are called product to sum and sum to product formulas. These over here are called the product to sum formulas because you have an expression here which is a product, things being multiplied, and I can rewrite it as instead of things being multiplied, things being added. See? This is a product, this is a sum because of the plus. You could also go backwards. If you're adding two things, instead of writing them as a sum, if you wanted to, you could write them as a product by doing this process. Sometimes in calculus, you're not going to want a sum, you're going to want a product. At other times, you're not going to want a product, you're going to want a sum. And so depending on what you want, you can go back and forth. Example, rewrite this product as the sum or difference. All right, so let's see. I have a cosine here. It's a cosine of 5x times a sine of 4x. So this is a product, and let's go ahead and take a look at which one of these I should use. So I have a cosine first and a sine second. So it's going to be this guy right here. So let's go ahead and use that. So we're going to say that the cosine of 5x times the sine of 4x is going to equal all of that. I'm going to write on the next line so I don't go over there. It's going to equal 1/2 times the sine of a plus b. Now, angle A is this one, angle B is this one. In my case, it's going to be 4x plus 5x. Sine of these guys together. And, oops, I messed up my parentheses there, sorry. And then minus the sine of the difference of these guys. There we go. Let's see what we get. So I'm getting 1/2 times the sine of 9x minus the sine of x. And that's pretty much it. You could distribute the 1/2 perhaps and get 1/2 times the sine of 9x minus 1/2 times the sine of x. And this could be your answer, or possibly the line above could also be your answer in factored form. So what we've done is we've taken an expression which was the product of two trigonometric functions and rewritten it as the sum or difference, in this case, of two trigonometric functions instead, or trigonometric expressions. Let's do it again. This time let's use some actual numerical examples. So let's do the cosine of 195 plus the cosine of 105. And we're going to find the exact value of these guys by using one of these little formulas here. So it's going to be the third one. If you look carefully, this is the cosine plus cosine. So I can rewrite it as this. So in other words, this time I'm using a sum to product formula. So I'm going to rewrite this using a sum to product formula. So it's going to equal 2 times the cosine of a plus b over 2. So 195 plus 105 divided by 2 times the cosine of a minus b over 2. So 195 minus 105 over 2. So let's see. This is going to be 2 times the cosine of, that adds up to 300, divided by 2 is 150 degrees. I'm going to keep parentheses here because we're multiplying. And this will be, that minus that's 90, divided by 2 is 45 degrees. Okay. So all I need to do now is go ahead and look at my unit circle, and I see in my unit circle that the cosine of 150 degrees is negative root 3 over 2, and the cosine of 45 degrees is root 2 over 2. So now multiplying, these guys are going to cross out. I can get rid of those. And so on top, I'm going to have negative root 6 divided by 2. If you enter this in your calculator, you'll get negative 1.22. Uh-oh, let me try that again. You'll get approximately negative 1.22. And if you were to enter this in your calculator and do the addition, you would get negative 1.22. So your answer is one of those two. Your WebAssign will probably want the first one, the one in radical form. WebAssign doesn't like rounding unless it tells you to. All right, and now that is all the identities and all of the formulas. We're just going to end with a little bit of a proof, a verification. In other words, we are going to verify that these things are actually equal. So here we go. Wow, I wonder if I can make that bigger. Feels a little small. Ah, there we go. Okay, so we need to verify that this equals that. So this is what we've been doing before. Remember, the rules are start with the more complicated looking side. So this side looks more complicated. So we're going to try to get this side to equal the cosine of 2x. Now this is a little bit harder because you don't know which of these identities or formulas to use. So you use whatever you can. Just look on this pink sheet and say, okay, what can I do? So one of the things you might notice right away, I hope, is that this is a difference of squares. And whenever you have a difference of squares, one of the things that you'll want to do right away, you'll want to factor that. So let's factor it. So this will be the cosine squared of x plus the sine squared of x times the cosine squared of x minus the sine squared of x. And that will equal the cosine of 2x. So I just factored this as a difference of squares. If you're not too sure, you can try it. You can try foiling it. And when you foil it, you will indeed verify that these expressions are equal. So the next thing I can do is I can look at my sheet and see, okay, well, what identities can I use? It should become very apparent to you that this is the one I told you to memorize. That the cosine squared of x plus the sine squared of x, that's a Pythagorean identity. And that is always going to equal 1. So go ahead and put a 1 right there. Now the cosine squared of x minus the sine squared of x, that might be a little tougher. So take a moment and look at your sheet and see if you see it. I'll give you a hint, it's somewhere in the middle. Right there. Double angle formula. Do you see it? So that is actually an expression that can be rewritten as, according to the double angle formula, the cosine of 2x. At this point, I'm looking pretty good, aren't I? I can basically say the cosine of 2x, equals a cosine of 2x. Boom, 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 boom. Quod erat demonstratum. And there you go. We have proven this identity. All right. Do a good job on this 5-5. And what we're going to do after this week is we're going to go back to 5-3 and learn to solve trigonometric equations. To solve it, you're going to have to know these identities that we just learned. Okay, if you have any questions, please do email me and let me know if you ever need to chat using Google Meet or something. I'm here for you guys. Just let me know what you need. All right, bye-bye.